Hello, very good morning. Today in our class we are going to discuss and see the constructional details and working of a hard drive. It's a hard disk drive. So what are the inside parts, how they work, what are the functionality of hard disk, how it read, how it works, all the things we are going to see in this class. So our topic is give the constructional details and working of a hard disk drive under the mass storage devices topic. So this is the typical hard disk. You can see under the hard disk construction. Here we see the main important component inside the motherboard where we store our data is nothing but platter. There are number of plates, 2, 4 or more plates are mounted on this area, and these plates are surrounded with under the control of spindle motor. This spindle motor spins these platers so that these runs in the form of certain runs per minute, 1000 runs per minute, 5000 runs per minute, 7000 runs per minute, like that, based on the hard disk type and technology. Here this is a read-write head which reads the information from these platers and write the information on these platers. To move this one, there is a device called actuator arm which moves this read-write head, and this one is the actuator axis which controls these two, actuator arm and also read-write head, and this is the actuator which moves this entire assembly, and this is IDE connector to connect the cable from the motherboard to this hard disk. This is jumper block. Here we have power connector which is coming from SMPS, which supplies the entire power to the hard disk drive. This is somewhat anatomy of hard disk, we can say. Here this is hard disk organization, hard disk drive organization. There is arm assembly, next come arm, after that head, and after that this is spindle, and cylinders are there. These are all plates. Here 3 plates are there. 3 plates are there. For each and every plate, separate read-write head is there. So this is general hard disk organization. So further we will see a video on this, how these plates are arranged and everything. We will see another video here.
I'm Joanne Larson. I work at Seagate in a design center. I have 2 drives here just to illustrate a couple of form factors that we design. This is an example of a 2.5-inch drive, as we call it, which would be used, for example, in a notebook computer. This is what we call a 3.5-inch form factor. A hard disk drive is so named because the heart of the matter is where the data is stored, which is on these disks, and the data is stored magnetically as ones and zeros, or as magnetic bits that are oriented north or south. It is read or written, as we say, by very small transducers on heads. So this little roughly triangular shaped feature can be thought of as the size of a bit. When we write, and this is the write pull, the flux is essentially focused through that pull. The corresponding area on the media below it is magnetized. The head is out flying on a suspension at the end of an arm. This is an arm, which is part of what we call the head stack assembly. The arms move back and forth across the stroke and read the various tracks that are laid out on the disk. These tracks are so narrow that we fit about 300,000 of them in an inch of radius. The arms, the HSA pivot, is actuated, in this case, and I think this is kind of fun, magnetically. As we know, electricity and magnetism exist together, and when a current is run through a wire, there is a corresponding orthogonal magnetic field. So how we are using that here is that there is a coil, it's actually hidden under this magnet. Under this plate there's a magnet, and below the magnet is a coil. The driving force of the current, or conversely the magnetism, forces the back end of the coil to move in one direction or the other. Right here we see the motor that spins the media. When the drive is powered off, the heads are resting on this ramp. The arm swings off so that the heads are preserved and they're not touching the media or anything. If I want to write or I want to read, in other words, if I want to record a picture or if I want to bring out a picture file, the arms swing out over the disc and the heads are flying over the tracks, as we call them. So it goes to a very specific radius and the drive will be given an address to go. Let's pretend that was the radius, that was the track that contains the picture or part of the picture. That is the file that we said, please show me this picture. The data is recorded in magnetic domains that are very small surface area on the disk. The transducer on the head senses for that domain the direction of the magnetism and whether it is a 1 or a 0, and that's a bit. The head takes all of those bits and transmits that electrically up into the channel. It is reconstructed back into a data form that we recognize as an image. What we are looking at right now is the surface on the recording head that's facing the media surface. So the disc is spinning under the head, and there's an airflow or shear between this air-bearing surface and the media surface. These darker areas are in relief outward, and the medium range is actually inward. And these surfaces in relief are functioning in the way that we would think of wings or the features on a jet that control the flow of air. Everything that we can see in this view is only to support what we call the transducer out at what is the trailing edge of the head, and it's where the magnetic flux is read and written, or where we control the flux back and forth between the head and the disc. This is a very close view of the transducer, and at the top, it's not necessarily possible to see here, but we'll show a picture in a minute, is what we call the right pole. It's a very tiny dot in the middle of a triangle at that location, and that's where the pole that writes is visible. Down in the middle of this stripe is what we call the read element, and that is the location where the magnetic signal is sensed for the read function. So our magnification right now is 85,000, and our micron bar is 200 nanometers. When you think about it and you think about the size of molecules, we realize that some of these layers that we're looking at are roughly a few atoms or a few molecules thick. That is particularly true of the read element, and it's just a tiny dot or sliver when we look at it even at 100,000x. and it has several layers which again are atoms thick at most. Very simple in concept and an amazing amount of technology.
So in the previous video we saw how hard disks are manufactured and constructed, what are the platers, how the plates looks like, how the plates are inserted in the hard disk, how they are constructed, and how these plates are spin according to the spindle motor, how the head assembly, hard disk head assembly, how the information is recorded in the platers, everything we have seen. So now we are going to see the several components. What are the components inside the hard disk? Say hard disk is made up of several physical components. These are disk platers, important component inside the hard disk, read write heads, head actuator mechanism, spindle motor, logic board, cables and connectors, bezel or front plate, air filter, head arm, head slider. So these are the important components inside the hard disk. Now we will see about each one. The platers stores information. Platers are nothing but where we store the information inside the hard disk. These platers comes in varying sizes like 5.12 inches, 3.14 inches and 0.85 inches, etc. The physical size of a drive is expressed as the size of the platers. Based on the size of the platers only we will express the physical size of the drive. Most hard disks have 2 or more platers. Platers are originally made from an aluminum or magnesium alloy which provides both strength and lightweight. All modern drives use glass or glass ceramic plates. So the older hard disk was containing aluminum or magnesium alloy, whereas the modern devices, modern drives are coming with the glass or glass ceramic plates to store the information in it. So next one, read write it. Every hard disk or floppy disk or everything must have a read write head. The hard disk drive usually has one read write head for each platter surface, meaning that each platter has 2 sets of read write heads, one for top side and one for bottom side. So if there are 4 number of platters inside the hard disk, there must be 8 read write heads to read the information from these plates and write the information on these plates. So for each and every platter there must be 2 read write heads. One is top side, one head is top side working and another head is working at bottom side. These heads are connected on a single movement mechanism, so heads across the platters in unison. So read write head again. The HDD uses various types of heads for read and write purpose. These are the types of heads, various types of heads. Ferrite head, metal in gap head, thin film head, magneto-resistive head, gained magneto-resistive head. So these are the types of heads generally used in any hard disk. The hard disk must contain platers. Each and every plate contains 2 heads. Top side of the one head is top side of the plater and another one is bottom side of the plater. So these are the types of heads we are using: ferrite head, metal in gap head, thin film head, magneto-resistive head, gained magneto-resistive head, and etc. Next one component is head actuator mechanism. So this mechanism moves the heads across the disk and position them accurately above the desired cylinder. So when plates are moving, nothing but spinning according to the spindle motor at a great speed, so the heads are moved front and back to the center of the plater and also outside of the uh, outside edge of the plater. So according to this movement of the information will be read and information will be passed and read on the plater. Two basic categories are used here: stepper motor mechanism and voice coil actuator. So these actuator mechanisms are used. Two types are there: stepper motor and Y-scale actuator. So stepper motor mechanism, one of the end actuator mechanism, stepper motor mechanism. Stepper motor actuators were commonly used on hard drives made during the 1980s and early 1990s with capacities of 100 MB or less. The earlier hard disks were started from 20 MB hard disk. Now the hard disks are available in the capacity of 1 TB and 1.5 TB and above. So the earlier hard disk was, first ever hard disk was 20 MB size, then after 40 MB, and then after 100 MB, 200 MB, and 1 GB, 500 MB, 1 GB, 2 GB, like that hard disks were developed. So before 100 MB and less, there were uses of stepper motor mechanism to movement of the actuators. Floppy disk drives position their head by using a stepper motor actuator. All hard disk drive being manufactured today use Y-scale actuator. The older hard disks were using stepper motor mechanism to move the actuator. Now we are using Y-scale actuator to move the actuator mechanism. Next one is the present one, Y-scale actuator. The two main types of Y-scale position mechanisms are linear Y-scale actuators and rotary Y actuators. Next one, spindle motor. The spindle motor spins the platers connected to a spindle. So all the platers are connected to a spindle. The spindle spins all the platers in a same speed. The motor is directly connected to the spindle of platers. These platers revolve at exactly 3600 RPM to 1500 RPM, 15,000 RPM, sorry. The speed of motor has to be controlled very preciously. Normally, a feedback loop is employed in the control electronics to monitor the speed. The speed control is fully automatic. Next one, the logic board, one of the important component inside the hard disk. A disk drive will have a board, nothing but logic board, containing the electronics that controls the drive's spindle and head actuator systems. These are called logic boards. They present data to the controller in a planned format. They may be removed and replaced to rectify a logic board problem. If any problem occurs, we can remove the logic board from the hard disk and insert new one. Then cable and connectors. Cable and connectors are used to connect HDD to the main computer system. All hard disk drive contains connections for data and control interface connector and also power connector. Bezel and front bracelet. Bezel is a front faceplate provided on most of the hard disk drives. Air filters. Nearly all hard disk drives have two air filters. One is called the recirculating filter and the other is called either barometric or breather filter. These filters are permanently sealed inside the drive and are designed never to be changes for the life of the drive. A hard disk on a PC system does not circulate air from inside to and outside the HDD or vice versa. The recirculating filter permanently installed inside HDA. HDA means hard disk assembly. HDA is designed to filter only small particles scraped off platters during head takeoffs and landings. So here we will see another video how the hard disk parts looks like. What are the hard disk parts, how they look and how they perform their work inside the hard disk.
An electric motor spins the hard drive's disk at exactly 7,200 revolutions per minute. The circuit board keeps the speed constant. And here's the crucial part, the actuator arms that hold the read-write heads. The ends of the arms are split, and right in the middle ride the disk platters. But the heads never actually touch the disks. The space between the head and the surface of the disc is 5,000 times thinner than a human hair. The heads float on a cushion of air created by the spinning discs. An absolutely essential cushion that prevents the head from crashing on the disc. And what a crash it would be. Talking about a crash is not only a metaphor. At these tiny scales, the weight of the heads really compares to the weight of a 747 airplane. A 747 airplane packed with 100,000 passengers, flying at 60 miles per hour, 1/100th of an inch from the ground. Ouch. There's no friction to slow things down, so the arms can move the heads to write or access data up to 60 times per second. The engine that drives the arms is invisible because it's an electromagnetic system driven by two forces of nature, electricity and magnetism, which makes the arms move back and forth across the disc at lightning speed. That's it for the components. Now here comes the data. The data is stored inside tiny concentric tracks on the disc's surface. During manufacture, up to 200,000 of these tracks are created on the disc. Each track is divided into sectors. A map of the tracks and sectors in the printed circuit board tells the heads exactly where to read or write information. The surface of the disc is smooth and shiny, but look closer. It's way more complicated. A magnetic film on the surface memorizes all the information. The heads magnetize microscopic sections of the film and store the data in a sequence of ones or zeros. Each one or zero is called a bit. The value of each bit is determined by the orientation of its magnetic field, plus or minus. And it doesn't take long for the bits to add up. One high-quality photo can take up 29 million bits spread across 12 different sectors of the disc. This sounds incredibly massive, but in reality, a stupefying quantity of bits can fit in an extremely small space. Each square centimeter of the disc's surface holds 31 billion bits. Now that's space-saving. A hard disk stores and recovers a phenomenal amount of information at speeds that defy comprehension. Using the power of magnetism, the shiny surface of a hard disk can store the contents of several sets of encyclopedias, or hundreds of thousands of images. Easy. The hard disk really is an amazing, shrinking machine, squeezing mountains of data into little bytes with a single keystroke. This masterpiece of engineering has really stretched the boundaries of physics, bit by bit. Coming up!
Just now we saw the internal parts, especially control board inside the hard disk and platers inside the hard disk, how they perform their work. So now we are going to see the terms related to hard disk. What are the terms related to hard disk? Generally, general talk and general usage of the hard disk. The terms are track, what is track inside the hard disk, sector, cylinder, cluster, landing zone, MBR, this is nothing but master boot recording, and zone recording, write, precompensation, interleave and interleave factor. And these are the terms related to the hard disk generally we use. So what are these terms? We are going to see about these 9 terms in this hard disk. First, cluster. When operating system writes some information on the hard disk, it does not allocate the space sector wise. Instead, uses new unit of storage called cluster. Generally, the hard disk is divided into hard disk platers. The plates are divided into tracks. The entire plate is divided into tracks, and each and every track is divided into sector. Sector is the basic unit, basic place in the hard disk to store the information. The clusters are the minimum space allocated by DOS. DOS is nothing but disk operating system when storing any information on the disk. Even to store only 1 byte long information on the disk requires minimum 1 cluster area on the disk surface. A cluster can be made up of 1 or more sectors. It depends upon a disk type being used. So already we have seen the hard disk platters are divided into tracks. Tracks are divided into again sectors. So here one or two or some more sectors form a cluster. So cluster can be made up of one or more sectors. It depends on disk type being used. This reduces the size of FAT, nothing but file allocation table, that does uses keep track of the used and empty disk space. First cluster number is taken as two clusters are used to allocate the storage area for data area only. FAT and directory areas are not allocated according to the cluster size. So your first cluster is taken to FAT, file allocation table. Cylinder, same tracks of different platters form an imaginary cylinder like structure. Same tracks. So already the track platters are divided into tracks which are in round shape. Same tracks of different platters form an imaginary cylinder like structure. So data is stored cylinder by cylinder. All tracks in a cylinder are written and then the read write it moves to the next cylinder. So according to this, the platters are spinning at a constant speed. The same tracks of different plates, nothing but assume that the tracks nearby the center of the spindle, center of the center of the platters of all the plates form a cylinder. The next side cylinders of all the platters form a cylinder, imaginary structure, imaginary cylinder like structure. Data is stored cylinder by cylinder, all tracks on the cylinder are written and then read write it moves to the next cylinder. This reduces of read write head, increases speed of a read write operation. Sector, a track is a big area to store data, nothing but 5000 bytes around, and tracks are divided into sectors. The formatting program divides disk surface into sectors by writing magnetic pattern on disk surface. So formatting is a program that divides the disk into sectors. When we purchase a new hard disk, nothing we can store on the information, that must be prepared to store, nothing but a program called formatting program is required, which prepares the hard disk to store the information by dividing plates. All plates are into tracks and again divides tracks into sectors and like the clusters, prepare the clusters on the hard disk. Different HDD capacities have different number of tracks. 512 byte data can be stored in each sector. Sector number starts from 1. So the unit of information can be stored in a sector is 512 bytes. So here we can observe, if you take a cylinder looks like in the round shape, and every cylinder is divided into tracks. These round shape lines are called tracks. Again, track is divided into sectors. This is sector, this is sector, this is sector, this is a sector. Like that, these all tracks are divided into sectors. We can say these are all sectors. This is sector, 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 these are all sectors. Here, 4 plates, if you assume 4 plates are there, there must be 8 heads on it, 8 read write heads. So information is stored in this sector only. So what is meant by cylinder there? This same example, these tracks, these 2 tracks, number 1 and 2, which are in 1 and 2, and another one, third one, the 3 tracks of a particular platter form cylinder. If we have 4 platters here, the 3 tracks of on each plate form a cylinder. This is the meaning of the cylinder. So our hard disk plate is divided into tracks. Tracks are divided into number of sectors. So our information can be stored in a sector, and cylinder is formed in the same tracks of each and every plater form as imaginary cylinder like structure. There we store the information. So here we can see again, these are all tracks on the disk. It's a track, and this is a sector. Blue color one is sector. This is also sector, 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 sector. This is a sector. So like this, every platter on the hard disk is divided into tracks first, then again sectors. So here we will store. So landing zone, what is meant by landing zone? This setting specifies the cylinder to which the BIOS should send and the edge of the hard disk when the machine is to be turned off. This is where the edge will land when they spin down. Modern drives automatically park the edge in a special area that contains no data when the power is turned off. That is nothing but landing zone. Therefore, this setting is meaningless and typically ignored. Landing zone. The most BIOS set this value to be the largest cylinder number of the logical geometry specified for the disk when auto detection takes place. So if the drive has 6136 logical cylinders, the landing zone will be set to 6135. So as we are saying largest cylinder, that must be landing zone where the cylinder, where the read must be safely landed on it when power turned off. In any event, a modern IDE, integrated drive electronics drive, will ignore this setting and auto park by itself. This is a specialty in IDE. Zone recording. One way to increase the capacity of a hard drive during the lower level format is to create more sectors on the disks, outer cylinders, than the inner ones. Because they have larger circumference, the outer cylinders can hold more data. Drives that use zoned recording split the cylinders into groups called zones, with each successive zone having more sectors per track as you move outward from the center of the disk. So because for reading or writing the information from the outer track, it is difficult. It may take some time because sector size is physically, geographically, the size is more in the outer track. That's why there are less number of sectors in the outer zone of the track, where the center zone of the track have more sectors information. So write pre-compensation. It is useful for drives using standard track sector format. Drives using zone bit recording do not require any pre-compensation. The magnetic particles used to write on the disk surface have north and south poles, like poles repel and unlike poles attract. In the outer surface of the hard disk platter, magnetic particles are far apart to be affected by the attraction and repulsion of the magnetic particles. This is a right pre-compensation in the hard disk. In the inner tracks of the hard disk drive, the density of the magnetic are very high and adjacent particles start to attract and repel. This will force to change the information written on the disk. To compensate for this shift of data particles due to attraction and repulsion, the drive can write the data apart or closer than required position. This is right pre-compensation. Now the tracks. Each platter is broken into thousands of tightly packed concentric circles known as tracks. These tracks resemble the structure of annual rings of a tree. All the information stored in the hard disk is recorded in tracks. Starting from 0 at the outer side of the platter, the number of tracks goes on increasing to the inner side. So starting from the outer side of the platter, 0, to the inner side of the platters. Each track can hold a large amount of data counting to thousands of bytes. And these tracks contains number of sectors to store the information. So next word related to the hard disk is master boot record, short for master boot record, MBR, a small program that is executed when a computer boots up. The MBR contains two elements, executable code and partition table. So that is nothing but when you switch on the computer, the BIOS starts working, the BIOS program starts working in the BIOS chip. Here master boot record, first call program is master boot record. The master boot record contains executable code and also partition table. So these are the terms related to the hard disk drive we have discussed now. So next we will see another video which tells the working of hard disk.
A home computer is a powerful tool, but it must store data reliably to work well. Otherwise, it's kind of pointless, isn't it? Let's look inside and see how it stores data. Look at that. It's marvelous. It's an ordinary hard drive, but its details, of course, are extraordinary. Now, I'm sure you know the essence of a hard drive. We store data on it in binary form, ones and zeros. Now, this ARM supports a head, which is an electromagnet that scans over the disk and either writes data by changing the magnetization of specific sections on the platter, or it just reads the data by measuring the magnetic polarization. Now, in principle, pretty simple, but in practice, a lot of hardcore engineering. The key focus lies in being sure that the head can precisely, error-free, read and write to the disk. The first order of business is to move it with great control. To position the ARM, engineers use a voice coil actuator. The base of the ARM sits between two powerful magnets. They're so strong they're actually kind of hard to pull apart. There. The ARM moves because of a Lorentz force. Pass a current through a wire that's in a magnetic field, and the wire experiences a force. Reverse the current, and the force also reverses. As current flows in one direction in the coil, the force created by the permanent magnet makes the ARM move this way. Reverse the current and it moves back. The force on the ARM is directly proportional to the current through the coil, which allows the ARM's position to be finely tuned. Unlike a mechanical system of linkages, there is minimal wear and it isn't sensitive to temperature. At the end of the ARM lies the most critical component, the head. At its simplest, it's a piece of ferromagnetic material wrapped with wire. As it passes over the magnetized sections of the platter, it measures changes in the direction of the magnetic poles. Recall Faraday's law. A change in magnetization produces a voltage in a nearby coil. So as the head passes a section where the polarity has changed, it records a voltage spike. The spikes, both negative and positive, represent a 1, and when there is no voltage spike, corresponds to a 0. The head gets astonishingly close to the disk surface, 100 nanometers in older drives, but today under 10 nanometers in the newest ones. As the head gets closer to the disk, its magnetic field covers less area, allowing for more sectors of information to be packed onto the disk surface. To keep that critical height, engineers use an ingenious method. They float the head over the disk. You see, as the disk spins, it forms a boundary layer of air that gets dragged past the stationary head at 80 miles per hour at the outer edge. The head rides on a slider aerodynamically designed to float above the platter. And the genius of this air-bearing technology is its self-induced adjustment. If any disturbance causes the slider to rise too high, it floats back to where it should be. Now, because the head is so close to the disk surface, any stray particles could damage the disk, resulting in data loss. So engineers place this recirculating filter in the airflow. It removes small particles scraped off the platter. To keep the head flying at the right height, the platter is made incredibly smooth. Typically, this platter is so smooth that it has a surface roughness of about 1 nanometer. To give you an idea of how smooth that is, let's imagine that this section is enlarged until it's as long as a football field, American or international. The average bump on the surface would be about 3/100ths of an inch. The key element of the platter is the magnetic layer, which is cobalt with perhaps platinum and nickel mixed in. Now, this mixture of metals has high coercivity, which means that it will maintain that magnetization and thus data until it's exposed to another powerful magnetic field. One last thing that I find enormously clever, using a bit of math to squeeze up to 40% more information on the disk. Consider this sequence of magnetic poles on the disk surface. 01011. A scan by the head would reveal these distinct voltage spikes, both positive or negative for the ones. We would be easily able to distinguish it from, say, this similar sequence. If we compare them, they clearly differ. Engineers, though, always work to get more and more data onto a hard drive. One way to do this is to shrink the magnetic domains, but look what happens to the voltage spikes when we do this. For each sequence, the spikes of the ones now overlap and superimpose, giving fuzzy signals. In fact, the two sequences now look very similar. Using a technique called partial response maximum likelihood, engineers have developed sophisticated codes that can take a murky signal like this, generate the possible sequences that could make it up, and then choose the most probable. As with any successful technology, these hard drives remain unnoticed in our daily lives unless something goes wrong. I'm Bill Hammack, the Engineer Guy.
So far in this class we have discussed about constructional details of hard disk drive and working principle of hard disk drive. What are the parts inside the hard disk drive, how they work, what are the terms related to the hard disk, so how the hard disk works. So far we have seen in the PPTs and also in the different videos. So this is about constructional and details and working of the hard disk drive. So in the next class we are going to see what are the jumper settings for a hard disk drive, the important part on the hard disk. So thank you very much.